Okay, so in this video, now I'm going to put everything together that we've been discussing about symmetry and this equation. So what we did is we found that the graph of this equation was symmetric with respect to the polar axis, symmetric with respect to the pole, and it's also symmetric with respect to the line theta equals pi over 2. So now if we put all this together, we can graph part of this thing and then use symmetry to graph the rest of it. Okay, so what I did was I found the first points for the first quadrant. Okay, so I went from 0 to pi over 2. Okay, so then I went by sixths. Okay, I could have done it by twelfths, I guess, which is from the previous. But nonetheless, you can still get an idea of the way this graph looks. So I did 0, pi over 6, which is 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So I basically went the span of the first quadrant, okay? And so I found that R was 0, obviously it starts here, right? And then it curves up to about 2.6, right? So 2.6, okay? Maybe around here somewhere. And then it goes to 3, which is right at the tip. And then it goes back down to 2.6 approximately. And then it goes back to 0. So it does something like this, okay? Now, at that point, I don't need to plot any more points because I can use symmetry. So the first thing I know is it's symmetric with respect to pi over 2. Theta equals pi over 2. Which means it's symmetric with respect to this axis right here. So that means I know the other side is going to look something like this. Okay. And then I also know it's symmetric with respect to the origin, which means this will flip over here as well. But then it's also symmetric with respect to the polar axis, which means I'm going to get something like that. So I get a 4-petal rose that is symmetric, has 3 symmetries, right? It's symmetric with respect to the x, the polar axis, the pole, and the line theta equals pi over 2. Okay? And again, you could find this, by looking at these points, you can also plot the other points because you know that this point is going to flip here. Now the other thing too is the directional. Okay, so that's the other thing too is how does the directional go? So in this here, it's going to go like this, this, this. Now if you keep going, the way this is going to go, it's going to go like this. And then it's going to go here. And it's going to go here. And it's going to go all the way around. And then it's going to keep going. Here. And then it's going to keep going. And then it's going to keep going again. And it's going to keep going this way. And it's going to go right back where it started. So it's going to trace it going up this way, and then it's going to go here, and then it's going to go here, and it's going to go there. So now to get the directional lines, yes, you would need to plot more and then see, oh, okay, it's going here. But see, but you've got the shape of it just by using symmetry, and then say, okay, how is this traced? So that's the other thing. How is this thing traced as it goes from 0 to what? 0 to 2 pi. So this is from 0 to pi over 2, and then it's going to go from pi over 2. I think that's the way it goes. Hold on. Yeah, because I believe this is going to go negative. Yeah. So I believe it goes like this. And it's going to go this way. And then from pi over, then it's going to go from pi, right? Pi to 3 pi over 2. Boom. And then from 3 pi over 2 to 2 pi. Boom. Right back to your start. Okay. But again, the main point of this video I wanted to show you was that we could graph this thing by using symmetry. So all we had to do was plot the first petal and then use the fact that it's symmetric with all three of those symmetries, and we could get the whole graph without doing any more plotting. Okay, and that's it. See you next time.